Hello all, welcome back. In this module, we will talk about the concept of series and parallel circuit as the title shows here. So the network or a circuit that you see here is called as electrical series network because we have this voltage source or a battery or a cell, and across its two terminal we have three resistors connected in series. So when you see that, you also observe here the loop is completed and all elements are connected in series with each other. So in such kind of network, we can understand the concept of net current and the net voltage. So here in this network, the net current is said to be same. So the current I, for example, coming out of this voltage source right here, that will flow into this network in the direction shown by this laser. So that current I can be equal to I1, which is a current flowing through resistor, then I2, which is the current flowing through this resistor, equal to the IN, which would be the current flowing through the nth resistor. So that's why we say that the current flowing through each of these individual elements are equal to the total current coming out of this battery. So in the series network, always remember the net current is always same. Now, what about the voltage? The net voltage is said to be the sum of all voltages across the components. It means the voltage that is coming, that is across this battery or across this cell, is the sum of individual voltage drops across these elements. So the total V is equal to the V1 plus V2 plus V3. So V is equal to sum of all these voltages across these elements. Now here is an example where the resistors are shown to be connected in series. The resistor R1, R2 up to there are nth number of resistors. So in mathematically or in analytical form, we can write or understand this in this way. The equivalent resistance of this network which are connected in series can be equal to, can be said to be equal to sum of all the resistance starting from I equal to 1 to the nth value of the resistance. Here I will take the value from I equal to 1 to the n. That is R1 plus R2 plus R3 plus up to Rn. So those, the total resistance is the sum of all the resistances present into the network. Here you see that resistances are connected in parallel, R1, R2 up to Rn. There are n number of resistors that can be connected in this fashion and they are all connected in parallel. That's why this kind of circuit or network is called as electrical parallel network or electrical parallel circuit. Now, in this case, if we want to calculate the equivalent resistance of this network, which is across these two terminal, so we see that R equivalent is mathematically is the reciprocal of this -1 indicates the reciprocal of the sum of reciprocal of all individual resistances connected into the network. So sum would be from resistance I equal to 1 up to there are n number of resistance and take a reciprocal of all the resistances present into the network. And finally solving this, we can write the equation, the reciprocal of, again -1 here, reciprocal of the reciprocal of all the resistances, 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn. So this is how you will get R equivalent. So hope with this simple slide, you got the concept of series and parallel circuits. So whenever you see these elements connected in this fashion, so that all the current into the network, the total current into the network is nothing but a current flowing through the individual components into the circuit, that is I equal to I1 equal to I2 up to In, you say that this is a series circuit. However, in the same network, the voltage V is equal to the sum of voltages across each component, that is V will be equal to V1 plus V2 plus V3 up to Vn, depending on number of elements there. Here, the currents into the total current into this network, that is I, will be the sum of individual current flowing through these individual components. That is I will be equal to I1 plus I2 up to In. However, the voltage, the net voltage would be equal to all the voltages across the individual elements. That is V will be equal to V1 equal to V2 up to equal to Vn. Okay, so I hope you found this module useful. If you did so, you can share it with others and stay tuned for more engaging contents like this. Till then, wish you happy learning.